Hi, this is Ayan Dasgupta, and this is my physics public video lecture. This video is about the fourth and final public video lecture, the physics of breakfast. The lecture was about three main points: the physics of coffee rings, scrambled eggs, and finally Cheerios. The first topic was about coffee rings, and how they're always darker along the edge, but not ever as dark in the middle of the circle. And the speaker basically taught us that this comes down to three main things: surface tension, adhesion, and cohesion. When the drop of coffee evaporates, the edges of the drops get pinned so the diameter stays the same. While we would normally think that it would slowly get smaller, causing it to the color to evenly distribute throughout the circle, because it gets pinned, the colors it deepens around the edge. And the reason it deepens around the edge is that while it evaporates, the spherical cap has the same diameter. So, in order to reduce surface tension, the things in the middle get pushed towards the outside, and due to adhesion and cohesion, they start to gather along the outside, so that when the coffee drop is evaporated, all of the colloidal little particles inside of coffee, they are all gathered around the edge, forming that dark ring. That's the gist of the first topic. The second topic was about the physics behind scrambled eggs and whether they're liquid or solid. To understand this, they did the creep test to basically see what type of properties they were. And after the test was done, it was seen that the scrambled eggs had more solid characteristics than liquid. And this could be in part to the fact that when you make scrambled eggs, you heat the actual eggs that were originally liquid. So in the process of heating, you actually break the proteins down to their very primary structure, which is the sequence of the amino acids. And then afterwards, all of those denatured proteins start to form a very complex matrix, a complex network of denatured proteins, and this gives it an elastic property, giving it more solid characteristics. Before it was heated, the amino acids the proteins had a very specific shape, so that it forced it to be more liquidy rather than elastic and solid, because there wasn't as complex of a network. And that's why scrambled eggs is more solid than liquid. The third and last topic of the lecture was about the physics behind why Cheerios clump together in a bowl of milk. The reason of this is also adhesion. Due to all the Cheerios having roughly the same density, which is obviously less than milk, they all sit slightly above the milk, causing them to have a slight upward sloping meniscus in regard to the milk. This causes them to clump together, because when they're closer together, there's actually less surface area for the water, or for the milk, so that all of it basically, when they're together, it makes it easier for them to stick together, because one, they're at the same level rather than just being islands, so they kind of clump together better, and two, because they're at the same level, they kind of keep their whole area a little bit higher up, because together they can keep it even higher. I thoroughly enjoyed this lecture because I always love learning the little details of things that you kind of oversee, like all these little things that happen in just your breakfast, because it shows you how so much is going on regardless of whether we notice it or not. And the part that I liked the most about this was definitely about the scrambled eggs and the creep test, because in high school I actually did a decent amount of research using the creep test on different types of hydrogels, because it would allow me to distinguish the different types of properties of different hydrogels made from different properties or different concentrations, and how they can basically mimic different things depending on how they would react under the creep test, depending on their viscoelastic properties. Thank you for listening to my video, and I hope you enjoyed it.